May I have your attention, please? Thank you so much, and a very, very good afternoon. Hope you're enjoying this conference and some really great sessions that we were able to witness in the morning session. I'm Rajiv Kazanchi from with Hitachi Consulting, colleague Dan Torchik with Hitachi as well. And it is our privilege, and we are very pleased to get a chance to introduce the speakers for the 6 sessions that are going to be taking place in this room. So our first session is going to be on using video analytics for improving operational safety. And our first speaker is glad to introduce Saiprabhu, who is the Director of Consulting Services with Hitachi Consulting. And he's a member of Hitachi Global Center for Innovative Analytics. He's been an enterprise architect focused on developing Hitachi's social innovation business. Sai has been part of the Enterprise Architecture Councils and has evangelized successful adoption of emerging technologies across multiple industries. Please join me in welcoming Sai, and glad to present Saiprabhu.
Good afternoon, everyone. Thanks for joining us this afternoon, talking about how we can use video in your business decision making. This morning there was a question about the topic of our seminar, big data. I love it when you call me big data. I'm pretty excited about that opportunity. We also see similar excitement with our clients. In the past couple of years, there are a lot of questions from our clients around big data, such as, what is it? When we talk about that, the clients do understand the characteristics of big data in terms of volume, velocity, and variety, and etc. But when you start to look at a picture like this, they relate to the devices that generate big data or that interact with the results of a big data analytics, or events that generate big data in the same way. So they can now at a higher level understand how dealing with big data can actually make some changes in their business. So after the higher level understanding about big data and how it can help their business, it always boils down to the fundamental question: do I have a big data problem in their mind? So here are a couple of examples that we hear that may indicate that you have a big data problem. I won't talk about all of this because in the morning sessions we saw quite a good example of what are these examples mean actually. So let's drill down to the specific use case that we're going to talk in detail about. We hear from a lot of our clients that we have been capturing video for a while, and we have them stored, and we sometimes go back to them in a reactive manner to answer some questions or to look at some things from a surveillance perspective or from a safety compliance perspective and so forth. They also want to know how we can do that better. Typically, when that is the starting of a big data journey from a client's perspective. So why do we deal with images and video? For starters, they are everywhere. If you look at your mobile platform and whatnot, it is very easy to capture video. Think about the systems that you have built in your organization that capture information about your business, like your ERP systems or your process control systems and so forth. Think about the cost and the effort that takes to build on such system, and compare that to the cost of a camera that can capture the video, right? We'll talk in more detail about how the information is processed, but video is getting captured everywhere, and it's quite easy. Interestingly, a lot of our clients, they think they manage the video also very effectively. We are not quite sure about that yet, but when you look at it, the way they think is, we get the videos captured, we put them in a DVD, and we store it, and we look at it when you needed it. That is the thinking today about how video is used. But in our innovation scenario, we can do more about that. The reason is, as we all know, a picture is worth 1,000 words. So when you look at a video frame or image, there are lots of information in there. And if we can convert the video unstructured information into your traditional transactions and what have you, then you know how to integrate that in your decision-making apparatus. That's what we're going to talk about. In the keynote address, we heard 5 years ago we did not have certain technologies. So if you think about how you built your decision support systems in the past, if there is a video or if there is an image, you never take that into your data warehouse systems. You always kept it aside. But now, today, there are technological options that exist that can take the unstructured data like in video and produce information that can be used. So here is the convergence of all these things that forces you to actually leverage the video data into business decision making. So how to leverage images and videos? The simple thing in my mind is think face detection. Today, if you take a picture on your smartphone or your digital cameras, you can see a little block put on the people's face, right? Or if the image has a face. So the technology is very available, commonplace. But if you apply the same technologies that identify face or any objects into identifying a generic object in your workplace. Say, for example, if you're on a shop floor, you're capturing a video, and you want to make sure, from a security perspective, a safety perspective, there should be a clearance from where a human is to where the equipment is. If you need to know that, if you can identify that particular equipment from a video, then you can make a decision about, hey, am I close or am I far away? Is it safe distance and so forth. So that's the kind of thing we're talking about. Once you start to understand that, you realize the use cases that can open up from processing video gets skyrocketed. A lot of times we see with our clients that the moment they understand this, they can rattle about 10 or 15 use cases in half an hour's time. Now the challenge becomes, okay, which one I want to focus? Because it is not, we don't mean to say it is a very straightforward application. We realize that these innovation opportunities that exist, and so comes the responsibilities of how we need to proceed with that. So whenever that happens, we typically follow our social innovation adoption approach. It's very straightforward. There are many frameworks involved in here that we have successfully used with many clients. So it's a conglomeration of those frameworks. We always start with a business challenge that they need to solve. What is the specific challenge that we are unable to solve with our existing technologies and processes and so forth? That is where we add value to it. Once you identify that specific business challenge, we then focus on, are there questions that you want to answer before you go on a big project? Usually there is. That's the reason why they are looking at the innovative technologies. So our proposal is typically we do a proof of concept, which is typically anywhere from 6 weeks to 12 weeks duration. And those proof of concepts are structured in such a way that they answer specific unknowns. In the case we're going to talk about, is it like can an object be detected when video is being captured on a fast-moving train? That is a question. So we identify a very focused question that we need to answer, or define a proof of concept, and then we go about executing it. And at the end, obviously, we are going to answer those questions that we've thought about. Some questions we will not have a clear-cut answer. And so we build a roadmap of how you go about adopting this innovation. So that roadmap framework, then we start executing and we change the dependencies and so forth at the end. So what we recommend is, a lot of times, which works well with the clients, the way to adopt innovation is start with a very small proof of concept, get your business behind that, and then you can start to build more and more of that. So to change gears, now we'll talk about the specific business challenge for this conversation. So the railroad transportation safety. So more people and more freight is being transported in the railway industry in this generation than in the past. So running a safe operation is very critical. So if you look at the Federal Railroad Administration used data from 2013, then they've found out that over 2/3 of the accidents are caused by human error and track defects. What is making the challenge is, in America, the railroads are spread across tens and thousands of miles going through rural areas and cities. And so the incidents where these accidents happen are distributed all over the place. So traditional method of we going to all those places and checking for the safety harness in place or not is becoming really very challenging. So the FRA itself thinking about applying innovative technologies to solve this problem. So here is the situation with the client that they talked about a need where our innovation can be very helpful in solving this problem. So how do we go about the innovation in the transportation industry? If you look at it from a safety perspective, the first step to achieving safety is, do I have the safety harness in place? Is the signs are in the right place so that when you're running your operations, you can do the necessary things? So the first thing they wanted to do was, all right, we need to maintain these tracks. We need to make sure the signage is in place and so forth. And we want to detect obstacles, right? Say, for example, there is a line of sight requirement as the train moves forward. So yeah, today the line of sight is clear, right? As the vegetation starts to grow, if we can define a threshold beyond which when the vegetation comes along, I got to send a crew to go take care of that, that kind of information can be accomplished. Think about having to do that over tens and thousands of miles of track. It's very hard. So this is where the innovative application of video processing using our big data technologies becomes commonplace or becomes more meaningful. So the way we do that is, Hitachi technology, we have a global research setup in Japan and in Santa Clara and in Europe. So there are a lot of technologies are being built, right? We're going to talk about the specific algorithms today. So as Hitachi Consulting, we find a mapping to these technological advancements to the business challenges and we identify. That's what we talked about earlier, defining a proof of concept. So in this process, this is what we landed as our safety compliance proof of concept. Quite simple. What we want to do is automatically identify the safety signage so that the manual inspections can be informed by the exceptions that distinct systems can generate. So we want to find out that the signs are in the correct place. This is very important. Right? For example, if there is a crossing and if there is a sign in relation to crossing need to be by a certain distance, there are some business rules to be followed. Is the letters in the right shape, or is the sign got tilted a little bit, and so forth. So they want to find out, are there any missing signs or any damaged signs, and so forth. And once you find that information in a video and integrate that with other data, they would like some exceptions to be generated, if there are exceptions. And if there is none, they also want to start using that as an asset database. So if you look at it, with the one task of identifying that object in an image, there are two business uses. One, I'm managing them exceptions. Second, my asset database management becomes more informed. So the way our approach is quite simple. We detect these objects, and then we integrate with the train metadata like track geometry or location information and train speed and so forth. The location information is available through GPS data. There are very sophisticated measuring devices that run along the tracks, and that's what we use for this purpose. So what's our overall approach? I like this slide from a perspective that I can relate this to our traditional BI. We'll talk about it in a minute. So we got the movies recorded or video recorded on a train using Hitachi cameras and what have you. And we pass that through a very common name. We call it generic object detection. It is the software that uses several capabilities. We heard about neural net. We heard about classification algorithms. It is those kind of algorithms are actually employed by the generic object detection software. And it highlights the things it finds from a visual perspective. But the key thing is that software outputs information like, where did I see the sign, and where in which frame it's recorded, and so forth. And so if you look at it, that kind of information is very easily integratable into your decision-making apparatus, right? But there are two ways in which we do this. One, we use an example-based detection. Other one is learning-based detection. In example-based detection, if I know that I have a very specific object I'm looking for, then I can give examples, right? On the other hand, if I'm looking for face detection, I don't have a specific face. All I look for is just a face. So I can give machine learning neural net algorithms that can help you detect that kind of stuff. So in our approach, we use example-based detection to solve the problem because we were able to get specific signs that we are looking for. So again, it's the same thing, right, as we saw earlier. But the key part, what I wanted to show here is, in real life, there's always going to be some problems. So our application, it took, the way we divided it was, there are some test samples, and then there are some training samples, and so we get the manually clipped images and so forth. But what happens is, in the red that you marked, you get some pixels identified as objects, which are not necessarily true. So here is how we measure the performance of our software. There are two classes that are desired and two are not desired. So the true positives and true negatives are good ones to have. The true positives are the ones that we are supposed to identify, and we did a good job. The true negatives, the one that we are not supposed to find, but we did not find. Just think about it. A 20-minute or 30-minute frame of a video can result in hundreds of thousands of pictures. So you're looking at each picture to find out where the object is. So the true negatives are very important. You cannot find something that's not there. The ones that are not desired are false positives and false negatives. In our case, we got more hits on the false positives. Basically, because of the angle in which the photograph was taken or the speed in which the train is moving, a tree or a small bush may look like a sign because it has a dark coloration and nothing on the bottom. And so we had some false positives come up quite often. So here is the approach that how we improve the accuracy. You could supply metadata to your big data learning systems, such as where am I supposed to look for the particular signs. Let's say there is a sign that is associated with your crossing. There are not very many crossings in that 30-minute video, right? So you can say, okay, start to look your big data analytics only in this part of your video. So likewise, we have levers that you can vary to improve the accuracy of your systems. So we all have seen this picture a lot, right? We know how it is, that there are sources and there are transformations, and you have a history and you can make a decision. Now superimpose what we just saw in the generic object detection here. So video collection acts as your source systems. The generic object detection looks like your transformation engine that takes your video, applies the big data technologies and learning algorithms, and produce your data that you can integrate with existing systems. This is a very attractive proposition because a lot of clients have sophisticated BI environment in place already. So integrating this image processing system, it becomes easy for them to leverage existing infrastructure to make these things much more effective. So what is our big business here? I know I talked a lot about the video and capture in a train. That is actually an example, right? But it's applicable in very many places. This is Hitachi's vision for social innovation business. And as you can see, there are many different industries this technology is applicable. Say, for example, in your shop floor environment, you're capturing the video. You can tell what objects that need to be looked for, identified, and then if it is geotagged, we can even say the position. And in a video, because everything is pixel, you can apply necessary geometric progression to exactly find where things are in relation to each other, and so forth. In addition, this basic technology is what is used in a lot of our other applications. Basically, these are helped by your big data technologies from both ability to scale. For example, these things can be deployed on a Hadoop environment, and that way you can process in real time and help with a lot of these questions. Well, that's all I have, and thanks a lot for listening to this presentation. Appreciate it.